All right, naming acids. Okay, I'm back again. Here we go. Now, you'll be tested on this, but again, when we test you on this, we told you all you need to know are the 25 polyatomic ions, okay? And you've had a month to do that. You're doing a rather good job with forming ionic compounds, forming covalent compounds. You've had a lot of practice. You're going to continue to practice. But we've seen that if you know your polyatomic ions, you can very simply name acids. But here's the catch though. We're going to give you this format, something very similar to this on the test. So when we ask you to name a few, okay, you'll have the format. If you pay attention, you know your ions, you should do these very easily. Okay, these are going to be free, easy points. And the cool thing is, something new we've never done before. This is something new. So again, this is something else you're going to have familiarity and experience with. Okay? You've already done the ionic compounds. You've drawn them out. You already know how to write formulas with polyatomic ions, assuming you've been studying. Okay, that's the big assumption right there. And managing your time well, not waiting until the last minute. Okay? You're also drawing compounds. You're looking at the properties of ionic and covalent compounds. You're doing a lot of work. You can do that. You can easily do this. Okay, so let's try this, see how it goes. Again, we'll put a couple of these on your test. But again, we will give you on a periodic table the information, the format on how to name these. But I'm going to go over this right now because you're going to see how very easy this is. Okay? So let's take a look up here. We have two types of acids, binary and oxy acids. Binary does not have a polyatomic ion. Okay? And the format of every name for this is hydro, root word, ic, acid. Hydro, root, ic, acid. Well, let's see what that means. Take a look at the instruction right here. I have it right here. It consists of two elements. HCl. Now, you look at this compound. You ask yourself, what is it made of? Non-metal, non-metal. Okay? Two non-metals. So right here, you've got hydrogen with one valence electron. Now you know hydrogen wants to gain a valence electron because you remember from before, its outer shell needs to have two valence electrons to be stable. Okay? Chlorine, on the other hand, is a halogen. And you should know this from last chapter. 7 valence electrons. Part of the most unstable non-metal family in the periodic table. So here's chlorine. I'll put it in white. And they've got 1, 2, 3, 4, 5, 6, 7. Okay? So chlorine needs 1. Hydrogen needs 1. They decide to share. So now this hydrogen has 1 of its own access to 1 more, has 2. This hydrogen is happy. This has 7 of its own access to 1 more. This chlorine is happy. So this is a bond. Okay, so how do we name it? Okay, how do we name it? It's not an ionic compound. It's an acid. Okay? Molecular compounds. Take a look. So here's the format for it. Okay, it's very simple. We can't call it hydrochloride, right? Because that's the IDE ending goes with ionic compounds, IDE. This is not an ionic compound. So how do we differentiate? Instead of IDE, we go IC to demonstrate that this is an acid. Okay, so it differentiates. So watch this, very simple. When you see one like this, hydro, right, and you see on the paper, right? You've got hydro, and that denotes the H. What's this? Chlorine. Okay, well, what's the root word? Chlor. Well, being an English teacher, that's scary. Chloride is an ion. This is not an ionic compound. There's no transfer. This is sharing. Again, this is not an ionic compound. It's not a metal-non-metal. See how much review we're doing here too? This is a non-metal combination. This is a share. This is not a transfer. So we go hydrochlor, not ic, acid. Hydrochloric acid. Hydrochloric acid. Okay? IDE endings will go with ionic compounds and a few polyatomic ions. Okay, so let's take a look at the other one, another one here. HBr. Okay, so again, non-metal, non-metal. Hydrogen has 1 valence electron, bromine has 7. They both have the same need, okay? Hydrogen wants to gain 1 to have a full outer shell of 2. again, see all the review we're doing here. Really pay attention. Bromine has 7, needs 1 more to have a full 8. So they both have the same need, so they share. So hydrogen, I'll draw that real quick. Here's 7 right here. Here's 1 of hydrogen. Right here. Look at that. 7 of its own, access to 1 more, happy. 8. Hydrogen, 1 of its own, access to 1 more, 2, happy. So let's take a look. How do we name it? It's not bromide. This is not an ionic compound. It's not sodium bromide. What's the difference? This is a metal. This is a non-metal. Do you remember back in chapter 1 when we started with compounds, I said, write down metal, non-metal. And you guys rolled your eyes. This is why. You have to differentiate. This is a metal, non-metal, sodium bromide. Here, you've got, again, non-metal, non-metal. It's not an ionic compound, so you have to have a different ending. So watch this. Hydro, bromine, brom, acid. And again, I shouldn't have capitalized the B. Hydrobromic acid. Okay? Ich, acid, acid. HCl, HBr, acid. Okay? Very simple. Fluorine, fluorine. Again, look at this. Man, dust is everywhere. Ask yourself again when you're like, oh, I have to write all this out. Back it out of comments. I know it's a metal, non-metal. It's not anymore. Okay? So we got non-metal, non-metal. So there's going to be a sharing of electrons, although it's going to be unequal toward 1 pole. Hydrogen has 1 valence electron. Fluorine has 1, 2, 3, 4, 5, 6, 7. Here's your bond right here. There's a share. 1 of its own access to another. Hydrogen is happy. 7 over here, 1 more, 8. Fluorine is happy. Okay? So is it hydrogen fluoride? No, that's ionic. With my mug. Non-metal, non-metal. We don't want an IDE ending. We don't want an IDE ending. So we've got here hydro, fluorine, fluoric acid. Okay. Hydrofluoric acid. All right, got that? So it's hydrorhodic acid, hydrorhodic acid. And again, we'll give you that. That's fine. We'll give you this, or we'll give you this. You do either one. But you'll be able to do that if you have this, and we'll give you that. Okay, we're not going to make you memorize. You've had enough. Okay? Very simple. And there's practice on the second page. Okay, now I'm going to erase this. And we're going to focus on oxy acids. Now, let me make sure you can see oxy acids, because I don't have a tripod today. So let's see what we got here. My tripod is my overhead. Okay, here we go. Now this is where the polyatomic ions come into play. Oh boy. Perrhenate. Now, we have a friend in one of our classes. I guess he's from Ohio. And big Ohio State fan. So I'm pretty impressed that an Ohio State fan could come up with this. Wow, I'm surprised. Anyway, yeah, I know they beat us 72-0 in 1996. I know that's what you're thinking. Okay, I know they beat it. I know they got up. I know Ohio State in 1990. I was there at the Horseshoe in 1996 when the game was 65-0, and Ohio State had a punt return for a touchdown. Right when they only had, I think, 8 guys on the field, and we had 11. Okay, look it up on YouTube. I know it's there. You Ohio State fan that likes to talk smack about that. I know. That's all great and wonderful. Awesome, great. But again, I'm really impressed that you came up with that. And we came up with this. We said, how do you remember perchlorate? Right? Super, most oxygens, superlative. He came up with it. I'll give you credit there, person. You did a nice job. The person's name rhymes with rage. Good job there, rage. Okay, here we go. Actually, that's not a bad nickname for you. Okay, here we go. Now, if you've got a polyatomic ion, okay, oxy acids, and you know many of them have oxygen in it, per and 8. If you have an 8 ending or a per prefix, ooh, did I say prefix? Per prefix or an 8 ending, you go ic, paratic. If it's going light, one less oxygen, or hypoitis. I don't know. But again, we'll give you this. Paratic, hypoitis, whatever you want to remember. Let's work it through. So let's take a look at sulfate. Here's sulfate. Okay? So how do you make an acid with the sulfate polyatomic ion? Okay, so watch this. Okay, you ready? Sulfate. It would be SO4 2 minus. Now you add a hydrogen. You add a hydrogen. You add a hydrogen. Okay? You add a hydrogen. This goes down here to form H2SO4. Now let's take a look at this. SO4. Look at the polyatomic ion first. You see that right there? You see that polyatomic ion right there? Okay. This is key. Go to the ion. Hydrogen will pretty much always be there because it's an acid. Again, we'll get more into that in chapter 4. Look at the polyatomic ion. Now look over here. Here's the problem. You got another polyatomic ion. This 2 came from up here. We brought that 2 down here. But look at the oxygens. SO4. It's sulfate. So if it's sulfate, is it going to be ick or us? It's going to be ick. So watch the format. This becomes acid. Look at that, SO4. Okay, H2SO4, okay? You see that right there? Very simple. Now I'm going to skip down to persulfate, okay? To persulfate. And I know we don't have to memorize that, but I want you to see it can exist. I want you to see the effect of one more oxygen, okay? Or no, you know what? Let's just stay with the ATEs first. Let's stay with the ATEs. Here's nitrate. Okay, here's the problem. What's nitrate? No, you are grounded to nitrate. NO3 negative. Okay? Well, how does it become an acid? You add hydrogen. Okay? Is that clear? Hydrogen positive charge. Okay? Now, look here. In order for this to occur, these cancel out, equal opposite alert. Stick them together, becomes HNO3. But here's the situation. What is NO3? Nitrate. It's the regular polyatomic ion with the ATE ending. So it becomes nitric acid. Okay? There's your new ending, IC ending. Okay? Nitric acid. All right? Let's take a look at the next one. Let's talk it through. I should have put perchlorate on there. Why did I do that? Oh well, there'll be one on there. Okay. Persulfate. Look at this. I don't even think they'll make you know this in high school. It's a 5. Now you look at this, and you see there's one more oxygen than sulfate. Persulfate. Okay? I'll give you the name. All right? And on the test, I'll make sure we only use perchlorate. Okay? Or permanganate. All right. So anyway, what do you do with this? You see, here's the polyatomic ion. So what does this do? This charge goes over here. Here comes hydrogen. Crisscross. H2SO5. That's the formula. Okay? So what is it? Focus on the ion. It's one more than the 8. And again, I will give you perchlorate. What do we do? So now it becomes not sulfuric acid. It's not sulfuric acid. Because that's H2SO4. How do we differentiate the extra oxygen? Per sulfuric acid. Again, so if you've got a polyatomic ion that begins in PER, the superlative, or the super ion with the most oxygens. Thank you, friend from Ohio. Anyway, you start with the beginning prefix per, root, ic. Okay? And you see that for pernitrate, 4 NOs. Okay, let's take a look at another one. Let's go one less. So instead of sulfate, let's work with sulfite. Okay? Add hydrogen to make it an acid. Drop it. you've got H2SO3. Focus on this. It's an acid because it's got hydrogen. Okay, and again, we'll talk about hydrogen in chapter 4 of acids. This is one less. This is sulfite. It's an ITE ending. ITE ending. Okay? Sulfuric acid is SO4. Ite ends in OUS. So take a look here. So instead of sulfuric acid, persulfuric acid, you've got sulfurous acid. And sulfurous acid, this OUS ending tells you it's sulfite. Okay? And then we'll take a look at another one. Here's nitrite, NO2 negative. And if I've got a hydrogen over here that wants to gain one somehow, equal opposites, stick it together, HNO2, right? So look at the polyatomic ion. Nitrate, what is it? One less, nitrite. So which way do I go? This or this? We go here. So if it's an ITE ending, use that and watch. So it's, ready? Nitrous acid. Plus. Okay? Again, if you know your polyatomic ion, we'll give you the formula. You follow that. It's just like polyatomic ion. Is it per? Is it ate? Is it ite? Is it hypo? Okay? And you just go right through. Okay? Here, let me switch this up a little bit. Take a look here. Look here. Here we go. Ready? Let's go carbonate. All right? Let's go CO3 2 negative. Okay? This is your polyatomic ion you're working with. You need hydrogen to make it an acid. Okay? So watch. Which way are we going to go? Are we going to go here or are we going to go here? It's carbonate. So we're going to go here. So we're going to go, ready? Crisscross becomes H2CO3. So it's a carbonate. You go to ic. So it becomes carbonic acid. See how that works? Okay. Let's do this. What's this polyatomic ion called? You got to study. Hypochlorite. Hypochlorite, okay? So it's a hypopolyatomic ion. Which way do we go? Here or here? Hypo, here we go. So it's going to have an OUS ending. So it's going to be, here's your formula, crisscross, equal opposite alert, HClO, hypo, right? Chlorous acid. Okay. So you're starting to see the format. All right? Throw you one more. Where's the polyatomic ion? Is there a polyatomic ion in there? Oh, it's binary. It's binary. Hydro IODIC. Hydro iodic. That's it. I threw that in there to see if you're paying attention. And no, I really was this time because we were so focused on the oxy acids, I wanted you to see the difference. Okay, so I want you to take a look at the first on the next page right here. Why don't you start then, pause the video. I'll give you the answers to the first 10. So pause the video. Okay, you pause it. Okay, now I'm going to give you the answers. The first one, HClO4. Okay, it's the perchlorate polyatomic ion. So we call perchloric acid. Perchloric acid. Okay. H3PO4. What's PO4, guys? Phosphate. So if it's phosphate, you go ic. So it's phosphic acid. Okay. HCl. Now you see a little AQ right there? It means aqueous solution. We'll talk about that in chapter 3. Ignore that little parenthesis for now. HCl, is that a polyatomic ion? No. Binary. Hydro, for the H, chloric, Cl, acid. Hydrochloric acid. Okay? Next one, number 4. H2SO4. Look at the polyatomic ion. It's SO4. SO4, 2 minus, SO4, sulfate. Sulfuric acid. Okay? Next one. NO2 is the polyatomic ion. It's nitrite. Nitrite. And again, see what's so cool? If you memorize these, you put in the effort, look at what you can do. It's all about effort. Nitrite. ITE ending. Okay? ITE ending. So we're going to have an OUS ending. Nitrous. Nitrous. Nitrous acid. HI in aqueous solution. Again, we'll talk about that in chapter 4 and why that works, and also what AQ means in chapter 3. HI, it's not a polyatomic ion. Hydro for the H, iodic acid. Hydroiodic acid. Oh, here's a good one. HC2H3O2. My gosh, I wouldn't make you draw that. That is, what's the polyatomic ion right there? What is the polyatomic ion right there? Acetate. Okay. Acetate. Acetate. We have an H behind it. Acetic acid. Acetic acid is that answer. Okay? Next one. 1, 2, 3, 4, 5, 6, 7. Number 8, HF. Is there a polyatomic ion there? No, it's binary. Hydrofluoric acid. Okay? Next one, H3PO3. What's PO3? PO3. That is phosphite. Okay, remember that? So it's one less. So it's going to have an OUS ending. What a creative name it's going to be. Phosphorus acid. And then the next one is chloric acid. Okay? And then I'll do 2 toward the bottom. Real quick, guys. I'll do 2 toward the bottom. See where it says nitric acid? The bell's ring. I got a class coming. I'm sorry. Nitric acid. Nitric. IC ending. Nitric. HNO3, and I'll do chloric acid. It's HClO3. All right. We will have a little time in class next week to review this, okay? But again, you should have a strong foundation, and you'll be fine. Again, you'll get the information, the flow chart, okay, in order to, hold on one second, class ready to come in. You'll get the chart in order to name these well. But I will ask for feedback next week. Okay, first time teaching it, let me know which parts really work for you, okay? See how you do. All right, very good. Good job. We'll do a chapter 2 virtual study guide. Looks like I'll have to make it on Monday. All right, excellent. We're done. Get working on it. Know your ions. Bye.